Okay. Yes, you can start.
Good day, everyone. Welcome to our national tutorial campaign. Our national tutorial campaign. We are trying to cover up the gaps. We are in a pandemic, and the best way to learn it is through such facilities. So we're trying to cover up all the gaps. Welcome, join in. Make sure that you are here every Saturday. We will be conducting these lessons here in trying to help you pass the year. Your teacher is Geneva Windlovu. I'll be taking you for Information Technology, grade 10. According to your ATP, Accelerated Teaching Program, you'll find that from term 3, you are supposed to be looking at looping. You need to look at what are loops. I'm talking of IT programming practicals. There is the theory part, there is the programming side. We are looking at the programming part for this lesson. So looping is part of what is required for you to know, and that's where we'll start from. Looping using Delphi. Okay, if we look at introduction to looping, there are generally programming constructs. The way you code, we call them programming constructs. We'll look at the general programming constructs that are available through any programming language. We'll look at the for loop. We'll look at its structure. We'll look at the application of the for loop. And at the end, we're going to tackle a few examples of the application of the for loop in a real program. So we'll do a little bit of PowerPoint here when we're still learning, and I will switch over to Delphi, where we are going to look at real programming, how you apply loops. Okay, we're starting now. When you think of programming, programming has got 3 ways of coding. We call them programming constructs. 3 ways of coding. It's either you are coding sequentially, which is called sequencing, or you are coding through selection, or you are coding through iteration. I'll quickly touch on each of these quickly before we go to what we want to look at, which is loops, which fall under iteration. Sequencing is simple statement after statement that are done one after the other. Sequencing, you're looking at lines that are done one after the other. That's sequencing. Whenever you're doing a program, you do the first line, you go on to the second line, you go on to the third line, you go on to the fourth line. You are following a certain order. You are following a certain sequence, a line after another. That's called sequencing. And then we have what is called selection. Selection is when we use the if statement. If you still remember, you should have covered if statement in term 2. The if statement, also you can use what is called the case statement. That is part of selection. And then finally, you have what is called iteration. Some people call it looping, some people call it looping or iteration. That's where we are. That's what we'll be looking at in these lessons. We'll start off with iteration. So if we can look at iteration, how do you represent that using a flow diagram or a flow chart? Remember, you are supposed to know how to draw a flow chart. Before you go on to any program, you should be able to design a flow chart. You design a plan of what the program will do. This is called the flowchart. And the flowchart has got its different symbols. I hope your teacher has already taught you these different symbols. The start and the end are the same. This shape, and then we have the parallelogram here, which is normally input and output. And then we have the decision, which is sort of a diamond. And then we have the rectangle, which is normally processing. So if we are looking at iteration, how does it fit in a flowchart? Here is an example. You click on, you start the program from start, and then you initialize I count to 1, and then you test if I count is less or equal to 5. If it is yes, that it is less or equal to 5, you do some statements and you make sure that you increase I count. Then this loops back, or it repeats, or it goes back to testing whether the loop, whether I count is less or equal to 5. I count has increased here by 1, it goes back here, I count is now 2. So it tests there, I count is still less than 5, it will do those statements, increase I count again to 3, loop again. After looping again, I count goes to 4, it's still less than 5, and then do the statements, increase I count to 5. If when I count is equals to 5, it will do the statements for the last time. Then thereafter, it is I count less than 5? No, so it will take the other route. This is the other route. Then it can go and do other statements and go on and stop. So this is a flow chart. This is a diagrammatical representation of iteration using a flow diagram. Make sure that you familiarize yourself with flow diagrams. You might be given in your exam a flow chart that you'll be asked to interpret into a program, or you're given a program and asked to draw a flow chart. Okay, so this is iteration in the flow chart. We move on to the different types of loops. Iterations are loops. We have firstly what is called a for loop. We have 3 types of loops. We have what is called a for loop. We have what is called a while loop. We also have the third one that is called a repeat until loop. So these are the 3 different types of looping, or 3 different types of iteration. And for the purpose of this lesson, we're going to concentrate mainly on the for loop. As time goes on, we'll look at the other loops, the while loop and the repeat loop. But for the purpose of this lesson, we're going to look at the for loop. The for loop runs at a defined number of, it runs a defined number of times. In other words, you have to specify how many times this loop is supposed to run. If I can quickly take you back to the flowchart that we had now. If you look here, here's the flowchart. There is already a defined number of times that the loop runs. You know the starting position, it will start at 1 and it will continue looping, repeating until it gets to 5. So there is a defined number of times this loop is supposed to run. So that's the property of the for loop. You have to know the number of times that it should run. That's the for loop. The second type of loop is called the while loop. The while loop tests the condition before it runs. It tests a condition while, before it runs. In other words, while mark or while I count is less than 10, do the following. So it will always test before it can run. That's why I wrote here, it tests the condition before it runs. So it will not run until it tests the condition. I can give you an example now with the COVID conditions that we have. While you feel like you are sick, then don't go to school. You will not go to school if you're feeling that you are sick. At home, you do your check. When you do your check, you see that you're not feeling well. And then while you are not feeling well, please stay at home. While you are fine, you go to school. So you test before you go to school. You test before you start your day. That's a while loop. While it is true, a certain condition or statements are done. That's the second type of loop. The third type of loop that we're going to look at is called the repeat until loop. This one, I said here, it is a post-test. It tests the condition after it has run at least once. It will repeat what is supposed to be done and then test afterwards. It will test afterwards whether that condition is true. That's why it's called a what? A repeat until. So this is a post-test, this is a pre-test, this is a predefined loop that tells us the number of times that a program can run. So there you are, three types of loops: the for loop, the while loop, and the repeat loop. In your theory exam, you might be asked to differentiate between these three. Differentiate between a for loop, a while loop, and a repeat loop. You make sure that you specify that the for loop runs a specified a known number of time. A while loop will actually do a pre-test before it runs, and a repeat loop will only test after it has run at least once. Whether the conditions are false, it will still run at least once. That's the repeat until. Okay, those are the three different types of loops. We move on to the for loop in detail. We look at the for loop in detail. As I have said, the for loop actually runs a defined number of time, a known number of time. You must know the times the repetitions should be done before you start the loop. So that's your for loop. I've given here a general structure of the for loop, or we sometimes call it the syntax. How do you work with a for loop? You type, I've actually put other words here in bold. Those words that are in bold are not changeable. For you to work with a for loop, there should be a for, and then there should be a to, there should be a do. And then for loop variable colon equals a start to end, do. And then I've gone on to put a begin there. I've also put an end over there. And then I say statement 1 and statement 2. By saying statement 1 and statement 2, you might have 5 statements that need to be done. You still put them in between begin and end. You have 1 statement that has to be done here. You still put it between begin and end. I'll just explain that further. But first of all, let's talk of the loop variable that you have here. The loop variable is a variable that runs from the start value up to the end value. And it tracks how many times the loop has been repeated, and this value should be ordinal. In other words, the loop variable here should be declared by you. You declare this a variable, and the variable should be ordinal. What do we mean by ordinal? Ordinal means it should have a non-sequence. It should be a variable of that should follow a certain non-sequence. So people like to use here maybe ik for ik colon equals 1 to 5. The loop variable should just be a variable that can be either countable or has a sequence. You'll see later on when we apply it what I mean by ordinal. And then the start value is the first value the loop starts counting from. The loop starts counting from the start value. If you want the loop to loop 5 times, your start value should be 1. For ik colon equals 1, you are starting from 1. And then we have the end value. The end value is where the last value in the loop. If we want it running 5 times, we can say for ik colon equals 1 to 5, 1 being our start value, 5 being our end value or the last value. And the last value is the one that will force the loop to stop when it has reached that number. The loop cannot run when that start value is greater than the end value. So this is your limit. This is your starting position. The for loop normally increases by 1 value in each and every run. If, for example, I said for ik colon equals 1 to 5, do. So it will always start from 1. It will go on to 2, to 3, to 4, and up to 5. It will never skip until you actually change the statement and tell it to use a step. But it actually follows a sequence, and the normal sequence that we know is we count from 1, 2, 3, 4, up to 5. So there you are. This is the general structure of the for loop. This is the general structure of the for loop. We'll actually look at it when we are coding so that we see how we can apply it in a particular program. I've given you examples. We're going to move over to Delphi and look at examples of how to apply this. But I'm generally going to be following this question. Here's a question that says, write a program that greets a person 5 times using a for loop. If you have only done if statement, up to if statement, you can still code this program, but you will not be able to use a for loop. But now we're going to apply the for loop and see how for loops actually help us code less in a more effective way. Instead of using many lines of coding, we can use just a few lines of coding. So I'm going to go through these questions in coding. We're going to write a program that greets a person 5 times using a for loop. And then we're going to use other different numbers of the same program to still greet 5 times. I'll be coming back to this slide to come and refer to it as we go through the Delphi programming. So I'll ask you that if you have your computer with you, please, if you have a computer with you, please make sure that you start off Delphi, whichever version of Delphi that you're using, start off your Delphi program. I'm going to guide you through how we can actually do looping 5 times so that it can greet 5 times. So we're going to write a program that greets a person 5 times using a for loop. I'm going to stop sharing the screen and then go on to the Delphi programming so that we do this particular question. Please keep in mind this question. Write a program that greets a person 5 times. Write a program that greets a person 5 times. We're going to make sure that we will actually code this and make sure that it greets a person 5 times using a for loop. Okay, so I'm going to stop sharing this and I'm going to start Delphi, but keep that in mind, greeting a person 5 times. I'm going to stop the sharing here. I'm going to load my Delphi screen. I'm going to share my Delphi screen. Okay, for you learners there, please quickly design a form with a button, greet me, and I've also used a memo here. Load your Delphi, put a button, and also put a memo. This is our output. So basically, you still remember the question that is on the other side, write a program that will greet a person 5 times, right? So when we click on this button, it should display here on the memo output 5 times, greeting the person. Remember, when you're designing your form, make sure that you use proper naming conventions. When you're dealing with a button, make sure that you prefix that as BTN. My button is for greeting, and I've prefixed that to BTN greet. It's very important. And then on the memo, here is my memo. My memo is for output, and I've named it as mem output. This is where my output will actually appear. Very important that you name your buttons properly. Name your buttons properly. So we're going to go on now and click on this button so that we code a program to greet a person 5 times. I'm going to double click on greet me. When you double click on greet me, you go on to the coding side. Here is the coding side. I'm ready now to start coding here. Here is the top part, the header section of our program, and I'm ready to code here. I'm coding on button greet. I'm coding on a button greet. And then if you still remember, we are working on the for loop. We said the syntax of the for loop is for loop variable colon equals start to and do. That's what we're going to do here. So firstly, I have to declare a variable. I have to declare a variable for the loop variable. So I'm going to press enter there and then click right here, put var, which is a short for variable. I'm going to say my variable name is I loop. I'll call it I loop because it's for looping. And please remember also, when you are naming your variable names, prefix with an I to show that it is an integer value. I loop, when I look at that value and that variable inside the program, when I see I loop, something just reminds me that it's standing for integer loop. So prefix with an I if it is an integer, you prefix with an S if it is a string, you prefix with a C if it is a character, you prefix with a B if it is Boolean, you prefix with an R if it is a real number. So I've prefixed mine with an I to show that it is an integer. Now, going straight now onto the loop, I go on to for. See, the Delphi program already gives me a structure. It gives me a skeletal structure of the for loop. This is sort of the syntax that I'm supposed to follow. And I know from what we were talking about, you say for, loop variable. So where it's highlighting here, where it's saying I need to put the loop variable. And here is my loop variable. I called it I loop. So I can come here and change that to I loop. For I loop, colony equals, my program is going to start from 1. I change that to 1, 2, and then it's saying list count here. Mine is going up to 5. Remember this? This is the loop variable. This is the start position, and that is the number of times or the maximum position. For I loop colony equals 1 to 5, it's going to run 5 times. Remember, our program is meant to greet someone 5 times. It's meant to greet someone 5 times. So after the do here, do not terminate, because we need all these things happening inside the loop. So I'll press enter here. And please take note, immediately after pressing enter for the for loop, I need all of us to make it a habit that we put a begin. Put a begin. I'll explain just now why I'm saying let's put a begin. Put a begin. The moment you put a begin and you press enter, the Delphi program provides you with an end. The lines that are going to be inside begin and end, all of them are going to be inside the loop. The loop here, it's not terminated. In other words, it goes on to begin, and then begin only ends when it meets the end statement. So all the statements that will be here are inside the loop, remember in the syntax that I had shown you, I put statement 1 and statement 2. So statement 1 and statement 2 are supposed to be in between begin and end. And please do not terminate that, because this is not the end of the line. It is only showing us where the loop is starting. Don't terminate after do. So after begin here, I want to display. Remember, this is a program that is meant to greet someone. So I'll go on and display. I'm displaying in a mem output. Remember, mem output, Memo uses .lines.add. So mem output, press a dot. The computer brings up all the properties that are there. I'll press an L and lines come in. Simple double click there. Memo output.lines.add. Press a dot again, press an A, or okay, it's right here. So double click on add. I'm ready to add a line in a memo box, in a memo tool. I'm ready to add a line. And what line am I adding? Remember, we said this program greets someone 5 times. So here I can go on and open quotation marks and say good afternoon. Good afternoon. And then close quotation marks. Remember, anything that is in quotation marks is seen as a string and is displayed as it is. It is seen as a string and it is displayed as it is. So our memo box is going to display good afternoon. So after that, I can safely terminate that line. I can terminate that line. Our semicolon is the one that terminates the line. And there we go, we are done. Instead of coding long lines or 5 lines of greeting, loops have allowed me to actually code a few lines. And this program is able to greet someone 5 times, saying good afternoon, 5 times. If I was still using sequencing, remember the programming code types, you can either code sequentially, a line after the other. You can either code with selection, or you can code with iteration. We are doing iteration here. This is the loop, it iterates, it actually loops. So if you were doing sequencing, you were going to code 5 lines of the memo greeting greeting 5 times. And that is actually working hard and not working smart. So please make sure you work smart, work with loops, and make sure that you make your work easier. So this mem output is inside that loop. This loop starts with I loop. I loop will start as 1. I loop starting as 1, and then it will display in a memo output. It will display good afternoon. It will come back, loop back here. I loop increases to 2, and then on the memo, it displays again another good afternoon. It loops back again. I loop now increases to 3. It comes onto the memo. It displays good afternoon for the 3rd time. It goes back. I loop increases to 4, it displays good afternoon. I loop increases to 5, and it displays good afternoon for the 5th time. Okay, so I'm ready now to save my program. I'm ready to run this program. I hope you have also create a folder there. I had already saved this program, so I'll click on save. For you, create a folder there, save it properly. I'm clicking on save. I'm ready now to run this program. Let's see whether it will greet us 5 times. I'll click on run. Here is run. Click on run. There we go. The program is running and it's waiting for me to click on the button greet. When I click on the button greet, what should happen? It should display good afternoon 5 times. It will loop and display good afternoon 5 times. Okay, there we go. I click on greet me. It displays good afternoon 5 times. So that's the use of loops. It has made my work so easy. I can easily display good afternoon 5 times. If I wanted it displaying it 10 times, I would have looped, check here, I would have looped here. Instead of looping from 1 to 5, I could have looped 1 up to 10 so that it can display good afternoon 10 times. So there we go. This is how you can easily work with a loop. It has actually done what the first question that we had read on the other side was saying. Remember, it was saying write a program that will greet a person 5 times using a for loop. So my program is working and I'm happy. I'm going to close this program. I'm going to go back to my PowerPoint presentation and look at the next question. We are still developing this program further and further, and then we'll come back and modify this program and make it better and better as we still look at the for loop. So I'll go on to run, on run, go on to program reset so that it can stop running. I'll stop sharing this screen and bring back my PowerPoint. I'm bringing now my PowerPoint to check the next question. Okay, here is our section where we got the question. It was saying write a program that greets a person 5 times using a for loop. We have actually done that one properly. So I want us to go on to the next bullet. I want us to go on to the next bullet that says use other different numbers of the same program to still greet 5 times. Use other different numbers of the same program to still greet 5 times. Okay, I just wanted us to see this one. I'll stop sharing this screen and bring back Delphi again. Stop sharing, bring back my Delphi screen. Okay, here is my Delphi screen. Why are we using other numbers? I want you to easily see that the sequence here it doesn't necessarily have to be 1 to 5. I can change here and say my loop starts from 6 to 10. I will not say from 5 to 10. If I say 5 to 10, my loop is now running 6 times. But if I say from 6 to 10, my loop is running 5 times. Take note of that. Those questions you normally meet also in the theory paper. They will give you a scenario like a loop is running from 6 up to 10 or from 5 up to 10. And we normally rush to say it's running 5 times because 5 plus 5 equals 10. No, it's not like that. For loop, 6 up to 10. 6 will be the first run, 7 the second run, 8 the third run, 9 the fourth run, and 10 the fifth run. So this loop still runs 10 times. I'll simply change my start and my end, and then save and run this program and see that it will still do the same thing like what we did when it was 1 to 5. So I've changed that to 6 to 10. I'll click on save and then go on and run the program. Here is my program, it's running. I'm ready now to click on greet me. It will still run 5 times, although it's starting from 6 to 10, but it's still running 5 times. So if I click on greet me, there we go. We still have good afternoon 5 times. But if I had said 5 to 10, the good afternoons would be 6 instead of 5, because there are 5 different numbers in between 5, and there are 6 different numbers between 5 and 10. So this is very, very important. And this also shows you that you can use any numbers here. You don't necessarily have to start with 1 to 5. You can even change this. Let's change this. I'm going to stop the running of the program. Program reset. I will change here. I need it running 5 times. I can still use 0 up to 4. I can still use 0 up to 4. It's still 5 times. If I say 0 up to 4, I click on save, and then I click on run. Still running. The program is still running 5 times. Any number that you can choose, any number, as long as there is a sequence, there is ordinality. In other words, there is a sequence that can be followed from the start number up to the end number. That's a for loop. So the question that we answered on the other side, it was saying change the start and the end numbers to run the same number of times. It was supposed to still run 5 times, and it is still running 5 times, although I'm using 0 to 4, although I used 6 up to 10. So all the numbers are at your disposal. Use those that you want. But for an easy program, you can simply use 1 to 5 if you want to use 1 to 5. And please, because I'm using 1 to 5, it doesn't mean that it cannot loop 10 times, it cannot loop 15 times. Remember, a for loop only works a defined number of times. You know how many times you need it to run. I needed mine running 5 times. You can make it run any number of times that you want. Okay, let's go back to the PowerPoint presentation and check again the next task that we're supposed to do. Okay, it goes on, use other ordinal type of variables on the same program other than the numbers. We have been using numbers now. We used 1 to 5, we used 6 to 10. I've also used 0 up to 4. But now here's the question that says, use other ordinal type of variables on the same program other than the numbers. So remember, ordinality talks of sequence. It is a non-sequence. So it doesn't necessarily have to be numbers. For example, now I'll just show you how you can use other ordinal variables to actually run the same program. I'll stop sharing here and then bring up the Delphi screen again. Bring up Delphi. Okay, here is my Delphi program. Allow me here to change the variable now from an integer. I'll go on and add C letter. C letter is standing for a character. C letter is standing for a character. And a character is not an integer, it is a character, char, like that. C letter is of type char. And you see Delphi is already seeing a problem there because I'm using I loop when this side is talking of C letter. So I have to come this side and also change that. I'm using a variable now called what? C letter. C letter colony equals, it will start from, allow it to start from A. Let me allow it to start from A. Remember A, look at that, from A to, if I need it running 5 times again, I would say A to E. I would say A to E if I need it running 5 times. So I'll put an E there. And please take note there, I'm using capital letters. The sequence should be the same case. If I'm using capital A, it should, the last or the end loop, the end number should also be a capital. Start letter a capital A, stop one a capital E. So the computer will know this is also ordinal. It will know the sequence of A up to E. It is ordinal. Remember, ordinal, I said there is a sequence. It doesn't necessarily have to talk about numbers. It's talking of a sequence. I'm ready to save this and run also. There is my program running, and then I'm able to click on greet me, still doing the same thing. So importantly there, you need to note that the program can use any ordinal data types, as long as that ordinal data types can actually have a sequence. As long as that data type can have a sequence. So this is what we have done. We have shown ordinality here from there up to the end. So I'm going to quickly do maybe the last question and then give you some tasks to do, and then we sort of discuss on what the problems could be in what we have done so far. So go back to stop sharing here and go back to PowerPoint. Okay, modify the program to still greet 5 times, but this time in a numbered format. Okay, it has a 1 and good afternoon, a 2 and a good afternoon. So in other words, it's actually following, there is a numbering system that it's following. Modify the program to greet 5 times, but this time in a numbered format. Okay, I'm going to quickly do this one, and then you are going to try this by yourselves. I'll stop sharing this and then bring the Delphi one more time. Okay, let me take it back to integer type. Let me take it back to integer. I had used I loop, and its data type is integer. And then here, instead of C letter, I go back to I loop. Okay, and then I loop is starting from 1 up to 5. But then now when I'm displaying, I need the numbers appearing. The computer already has I loop, which is carrying a number. So if I come here inside here and say the output should say from an int to string of I loop, and then plus And then you know the separator, the tab separator, which is #9 plus. If I put it like this, memo output.lines.add into string I loop will be those values 1, 2, 3, 4, 5. So I'll see greeting 1, greeting 2, greeting 3 up to greeting 5 numbered. So there we go. I'm ready now to run this program. I loop is an integer we are displaying in a memo box, and memo box is a string handler, so we need this converter int to string so that we convert this integer and it is displayed in a string output. I'm ready to save this, and then I'm going to quickly run. Okay, and then click on greet me. There we go, 1. And then remember, this space is the #9 position. That space is the #9 position, and then it says good afternoon, and it lists my I loop. These are my I loop values as it runs through. First time it is 1, second time is 2, 3, 4, until it gets to 5. So this is how simple for loops could be. I've used the different ordinal types, and I'm going to stop this program. After stopping this program, get back to maybe the PowerPoint, and then check what you guys can do so that when we meet to on Saturday next week, we see how far we are, whether we understood this. So I'm going to stop the sharing here and then go on to sharing my PowerPoint. Okay, look at this. Add another button to display the same output as the previous, but in the reverse order. I need you to try this one out. I would need you to try this one out, and I need you to understand this. When we talk of the reverse order, you now put the end value here. Loop variable colony equals end value down to, you don't use 2, now you use what? Down to the end, to the start. For example, if we wanted 5 to 1, for loop variable colony equals 5 down to 1 do. And then your output will now look this way: 5, 4, 3, 2, 1. I'll repeat that. I need you to try it by yourselves. For loop variable colony equals your end or your highest value here, which could be 5 if you're running 5 times, 5 down to 1 do. And then here still maintain the same thing, and it will display your 5 and your greeting statement, your 4, your greeting statement. That is the task that I want you to try and do. I'm going to sort of open up this to hear if ever there could be any questions that might be arising, and then see how we can solve that. But just to maybe sort of summarize what we have done now, the for loops run a defined or known number of times. A for loop uses ordinal data types. Ordinal means there is a sequence. Values start from the smallest to the biggest, or vice versa. This is the one that I want you to do, or vice versa, if you use down to instead of 2. So in other words, it was saying 1 to 5. You can say 5 down to 1. Remember to put your statements between begin and end. Our display statements were between begin and end, and do not terminate after the do statement. Okay. Are there any questions, any queries on what we have done? I still have my program if you want me to go to the program and look at it again. Any questions? unmute yourself and speak.
There is a message on the chat session. Someone just thanking you. From Acacia, no questions today. Thank you so much. This helped me very much.
Okay.
Okay,
let me quickly check the messages on the chats. Okay, thank you, Acacia. Basically, we'll be doing this session, we'll be continuing with this session next week. Please make sure that you're there. Remember to practice all the skills by yourself. A skill that you do not practice is as good as dead. Your exams are coming up soon. Please make sure that you practice. And here is my email address. If ever there is any question, any queries that you want to send to me, I'll leave this screen on for some time. You can copy down that email address and send me the email and the query. But if there is nothing else, I'm happy to say we'll see you next Saturday at the same time. Thank you very much for being part of this lesson. I appreciate it.
Okay. Thank you very much once again. We've really and I'm very sure those that were on this call enjoyed the session, and those that would also join or listen to the recordings would enjoy the session. So yeah, we meet on Saturday. We meet next week.
Thank you very much.